Thank you, Albert, and thank you all for signing up for this webinar. I'd like to extend our apologies for the problem causing this to have to be rescheduled, but glad you were able to attend. We're going to be talking about root cause analysis and tools, and I think we appreciate the fact there's any number of ways to approach root cause analysis. So I'll be explaining the approaches I have used in the past. Of course, I switch around a little bit, and you'll see that as we go in here. There's several approaches that are even allowed as what we discuss here. There's no one way to do this, and there's a lot of iteration, reiteration. Hopefully what you'll see here is a general flow of ways to attack a problem and resolve it and monitor it, and some of the tools that you might want to consider to utilize in doing so. But it's not an exhaustive discussion. There's no way to cover all the potential ways one can try to pin down and resolve problems. But we're going to present an approach that does work, and it's a skeleton of the approach I generally have used for many, many years. So hopefully you will see the benefits of some of these points, may be able to adapt a few of these. I'm going to present this in a somewhat linear fashion, but in reality, there's, as I mentioned before, there's a lot of bouncing back and forth, a lot of reiteration in the process. It's not a smooth scientific approach, although some of the tools are somewhat scientific. They're statistical, which are only as good as the underlying data and assumptions. But as we go through this, I think we'll appreciate it's better than nothing. It's an approach that as you select the key points and then document that approach into an SOP and finalize it, make it a institutionalized methodology in your company. It's an approach that will be accepted by your regulatory agencies, as we'll kind of sum up at the end. I think all of us appreciate the fact that all regulatory agencies expect companies to have closed-loop systems regarding problems. Good ways of capturing problems, ways to analyze what's causing those problems, and then ways in which to resolve those problems and keep them resolved. So again, these are some of the issues that the FDA has mentioned in some of their 483s on their website. The fact that failure investigations are not completed in a timely manner. Generally, the FDA defines that as under 30 days. Now, that doesn't mean you can't do that. It means that you have to have a written policy that explains how you address something that goes beyond 30 days. And there's ways to handle that. Sometimes after several 30-day increments, you may want to close it out to a project if it's still open. But the longer it's open, the more questions you're going to get from an auditor, and the more questions you should have as a company, because your goal is to resolve these problems in a timely manner. The longer they stay open, the greater chance of shipping a questionable product that is not safe and effective as it could be. A product impact, we're going to talk about kind of two definitions of that term, and one that's neglected. And then the fact that the investigation is not taken to the real root cause. Now, that's more common than you'd think. There's nothing wrong with the fact that you may not have done that the first time through, but you have to have a system in place to recognize that fact when you see that your assumed root cause is not the root cause, or there may be more than one, and go back in and continue to work at it until all root causes are eliminated, if there's more than one or if you haven't identified the true one. And then, of course, documenting this activity, crucial in any CGMP environment. Again, notice here, sometimes complaint investigation, nonconformance investigation, out of specification condition investigation, what we're talking about here, all under CAPA, for example, are shunted to the side. No one individual or department is assigned to it, especially in a medium-sized or smaller company. This can be a problem because other people, engineers, for example, quality assurance, they have specific requirements that they're being judged on, that they have to meet, and frequently complaint resolution or problem resolution is not one of those things. It should be. To be effective, it has to be. But nevertheless, this is a finding the FDA has, and these complaints are primarily FDA issues, 483 issues. The investigators, that's the in-house failure investigation, lack proper expertise and or training to do an investigation, to do a root cause analysis. And then, of course, this bottom one is probably the big one, the fact that other priority work takes precedence. The FDA does not like to see that, but in reality, that's frequently what does happen, putting this on a back burner. Okay, you're going to notice that I have a blue slide to address each one of these 4 areas. Now, this is the title slide, but there'll be 4 additional slides that are with a background in blue to emphasize the 4 key steps in problem solving and resolution. One is to identify and document the problem. Now, that seems obvious, but in reality, sometimes we document the symptom and not the problem. So it's not as obvious as it might seem. If we don't get the right identification in place, the subsequent downstream activities are going to be a lot of wheel spinning, for example. So it's important to focus on or figure out what is the real problem or problems here. Easier said than done. The second is to start investigating it, and that we do the various tools we use and systems we use in root cause analysis. And then once we determine and identify the problem or problems, then sometimes that points toward a solution, sometimes it doesn't, but we have to come up with the methods to resolve this problem. Now, we're not talking about rework, we're not talking about recalls and things like that. That's activities you do to correct issues, but it's not corrective action, it's not preventive action under CAPA, for example. So after you resolve the immediate issue by replacing product, by quarantining product, whatever, you still have to address what caused that event to happen. And that's what we would be talking about here. And then figure out a way to resolve that, to permanently put it to bed, so there's no more firefighting, implementing a solution. And of course, what we do is under change control. And then we monitor to make sure we resolved all the issues. One of the biggest problems in warning letters is the fact that an FDA audit shows that there's a problem. They issue a 483. The company responds with proof of complying in resolving the problem. And then several years later, the FDA comes back and sees the same problem. Now, I have a slide toward the end that talks about entropy as to why these things occur when a company really did make a good effort to resolve the problem. But it's important to monitor to make sure. And although I don't focus on one type of monitoring, I'd like to emphasize it right now, and that is your internal audits. Make sure that if you know an audit is coming up, say from an external source, a regulatory agency like the FDA, you may have a week or so notice. Use that time to look at your past 483s and make sure they all haven't come back to haunt you, and resolve them if they have. And that should be part of your annual audit program, internal audit program. But we're going to focus on other areas of monitoring as well, in-process monitoring, production process control, that kind of thing in general. Okay. I have a little footnote here. Investigation template example can be an informal sequence of events or formal SOP defined. Ultimately, you want to get to the point where it is formal and SOP defined. Now, if you're a small company and you rely on maybe an engineer or a QAE or just a QA person or even a QA manager in a very small company to do these kind of things, initially it may start out with just an informal sequence of events, but they're going to have to go through something similar to this. Once they see it works and works repeatedly under various circumstances, I would certainly recommend that it become a formal SOP-defined methodology. So it's not dependent upon personnel, but it's dependent upon a defined system, if you will. Now, you notice I mentioned I have an executive summary, the second item here. You may or may not want to do this. This is a template of the steps you would take, the areas you'd have to consider. You may choose to change the sequence. If it's a large report, I'd certainly encourage a summary or executive summary up near the front so a person could quickly review this document without wading through 5 or 10 pages and quickly see what happened and what was done to resolve the issue. And then, of course, the specifics would be under the various headings. Now, obviously, this could not be a one-size-fits-all. You'll have to expand and contract these areas depending on how lengthy the study is, and that may mean if you left, say, a paragraph under corrective action, you may want to add some additional references to attached documents, if you will, whether it be e-documents or paper documents, to expand upon that. So this could be even a cover letter or something similar to that. It's up to you, but I include this to show the kind of things that should be considered in a investigation template which would address root cause resolutions of problems. Now, a little bit of definition here. Corrective action, preventive action are taken from CAPA, corrective and preventive action, obviously, and that applies to all models, if you will, FDA GMPs, pharmaceuticals devices, European Union, ISO 1345, all those kind of issues. Generally define those terms pretty much the same, but here's the definition I generally work with. A correction is not defined by CAPA, but it's involved in CAPA, and that's where you actually resolve the immediate issue by quarantining, recalling, replacing, if you will, with the customer. Those are the kind of activities as to correction. It just replaces something. It gets something that's usable out to where the other item that was unusable is pulled back and labeled as such. But now you've got this other item and you've got a problem that still exists. This is where corrective action and preventive action comes in. Corrective action is to address the issue that's at hand. Preventive action is generally to address issues that may not be readily apparent. It might be a systemic issue. It could be something totally unrelated that hasn't caused a problem necessitating a correction. But again, that could be involved here as well. You may see related issues. That generally would be under preventive action. You as a company would define these within the general definitions that are found there in the GMPs or in the ISO documents that you're under. Now, if you are under ISO for CE marking, for example, for selling outside the United States, work with your notified body. They may have their own preferences, but what we're talking about here has in the past passed FDA audits and remediation activities and various ISO notified body remediation and audit activities. But if you are dealing outside the United States with a regulatory body, make sure you know their preferred definitions. Effectiveness of this would tie back to monitoring, any attachments, and then, of course, the series of approvals on that, where you may have separate areas as well. This is an idea of the issues you should address in a complete problem resolution. So remember, I mentioned this, the initial blue slide with the 4 steps. Here's the first one. Obviously, you have to identify and document the problem, not the symptom, but the problem. So when we say systematic, this means a defined methodology. It doesn't mean it's dependent on individuals with charisma or special skills, although that might enhance it, but it's a system that's been defined. So ultimately, like I mentioned earlier, whatever you come up with ultimately should be defined in an SOP or a work instruction, generally in an SOP, so a standard operating procedure. And so this is explained to define how you go through a root cause analysis sequence in general. You don't want to tie people's hands. You don't want to require real extreme documentation for a very simple issue, nor would you want to have a simple documentation, incomplete documentation, for a very complex problem. So your SOP or your system definition has to be written in such a way that it allows for a certain amount of variance, if you will. Again, you're going to find that if you're expecting a very linear scientific approach here, it's totally impossible to really come up with that. I will come up with a very generalized approach, and you can pick and choose how you want to utilize these tools, and you'll probably find yourself shifting around a little over time as you utilize these type of principles or enhance the ones you're already using. Okay, obviously, as part of your process, and we're going to come back to data and metrics, etc. Incidentally, the FDA is, with a new draft guidance document, is talking about data integrity more and more. And I found when they audit companies, they're more and more questioning the choice of data that's being evaluated, the choice of metrics that have been selected, and the methodology in capturing and measuring those metrics. So it's important that the person analyze this. You may not be doing this right at this point. I find in the entire root cause analysis process, you're always coming back and examining, am I collecting the right data? Do I need to collect additional data in a different area? You will find that's a common issue. Something will point you to an area where you haven't been collecting anything in the past. So now you have to implement something, if not permanently, at least temporarily, to resolve this specific issue. If you can resolve the specific issue without adding a permanent data collection methodology to what you already have, fine. But in some cases you may have to. Other cases, a lot of this may be temporary gathering until you resolve the root cause. So that's something we'll be revisiting throughout the root cause analysis process. Determining what they are and then figuring out ways to record and capture that information. And then, of course, you'll always be doing a Pareto analysis, ranking major to minor, because you have limited resources, limited, that's time, budget, personnel, etc. No matter how big the company, how small the company, it always seems those resources are very limited. And there's competing claims on those resources. So you have to rank them and define them. I've never seen the FDA to date question something ranked low on a Pareto chart. It's visible, it's addressed, it may hang there for many, many months. Again, that gets into that issue we talked about earlier by closing things out within 30 days. But in some of those, you may not even have assigned them a project. They're just there, they're visible, they have no safety and efficacy issues. Maybe it's a color issue or something like that. But the key ones, the major, these are issues that affect safety. These are issues that affect a person's life or death, or the need for surgical or medical intervention type issues. So those are the things that have to go to the top of the line. Now you'll notice this next bullet point, I say impact to end user, that'd be your patient, clinician, but also impact to the business. The FDA could care less about business impact, dollar impact, scheduling impact, contract impact, those kind of things. However, they are interested in scrap rate and fall off. You may think that's a purely business matter, but it isn't. It's usually an indication of whether or not you really have a system in place to manufacture something. And I've even been involved in expert witness, being an expert witness where this was an issue. And the FDA won its argument in the court in terms of fall off and scrap rate being an indicator of whether a company really had a system or whether it was kind of an arts and craftsy type inspect quality in approach. And bear in mind that we're looking at both products and or process issues in this. Hopefully in your root cause analysis you can tie it down to just one of those, but frequently a product issue may be tied to a process issue. And these are things you'll have to determine. The product issue might be the symptom, and the process issue may end up being the actual root cause. So these are things to keep in mind. And then, of course, once you've attacked the major issues, again, major based on patient health and safety, then you work to the next ones. But you'll find that Pareto list changes monthly. And frequently other things come to the fore that weren't even identified, pushing the other ones out a little bit more. You have to figure out how you're going to address that. But as I mentioned, some at the very tail of that Pareto chart may not get addressed in a very long time, but they're visible, and you just have to have a rationale in place, predetermined, to explain why those haven't been attacked, why they are at the tail end, why they're low risk, if you will. Okay, one of the best initial tools, actually there's three I like to use. One is a flow chart, and we'll talk about that. One is the Ishikawa diagram, or fishbone diagram, cause and effect diagram. And the other is this one, which many of us tend to blow off, but it's from Six Sigma. I think we appreciate the fact that you You have identified, you've separated symptom from the actual problem. So now you've identified what the real problem is. Now maybe when going through this, you might reevaluate and determine, oh, you haven't really gotten to that real problem definition. But ultimately, you'll get to the real problem definition, and then you ask, why does that problem exist? And that'll lead you to a statement or several statements. So several statements may cause several parallel paths of 5 whys. But however, once you answer that question, it gives you a statement or statements. Then each one of those statements, you ask why that statement exists. And that leads you to another one or more. You may see a branching here. But generally, by asking these questions, you gradually get down to the bottom. It may be less than 5, occasionally be more, and in many cases it'd be, as I mentioned, a parallel series of 5. But it's a very powerful tool. It seems simplistic, but it is a very powerful tool to help you drill down the noise and get to the real root cause or causes of your issue. And you notice there, iterate. We're going to be doing a lot of iteration in this. It's like R&D. It's a lot of trial and error type of approach. Again, getting back to this point about getting away from symptoms and getting to the problem. So once you're able to clearly show what the problem is, and again, you can end up finding that that's not the case later on with some complex situations, but in most cases, after some back and forth, you come up with what the problem is or problems are, and you state that in your document, like that failure investigation template I mentioned earlier or something similar. Anyway, in your findings, whether it be in a lab book or in a special report, attached maybe a CAPA document, whatever, wherever you're putting all this information together to show how you arrived at what the problem was and then how you arrived at the solution to the problem and the resolution of the problem, putting it to bed forever. Again, here's some of the things that when you're defining a problem, and I've used all these things. This is not theoretical. I have actually used these. I've used them in situations, too, where I was dealing with a situation where there was an adversarial relationship between the company and the FDA investigators. And this is kind of the approaches we use that were acceptable to them under what I would consider less than ideal circumstances. I've also used them many other times as well, but this has been field tested under probably some of the worst situations imaginable in a regulatory environment. And you notice some of these things are, as I say, they're obvious, but when you actually commit them to a document, sometimes things jump out at you that you dismissed as being obvious. That last bullet point, a comparison of what it is to what it should be but isn't. Now that seems a no-brainer, so to speak, but I would not neglect that step. I would actually record, this is what we see, this is what it should be, and here's where it isn't, where it should be. Because that'll start pointing you in the right direction as to, do I really have the right root cause, and starts pointing you toward solution to that root cause, to the elimination of it. Okay, our second of the 4 key steps is the investigation. Here's where you get into a lot of different tools. In your CAPA system, for example, which drives a lot of root cause analysis, you do 2 things. Basically, you react to major problems in CAPA, but then you also do trending. And in some cases, you may have moderate problems, less severe problems, but there's a huge number of them. Now, even though that may be a major resource issue to your company, it is also a big concern to the FDA. It points to problems that even though it may not be a high safety issue, the frequency of the problem indicates a poor quality issue that isn't being resolved. So we're looking at the nature of the single incident in terms of its risk to the end user and the occurrence, frequent occurrence of a less major issue. Both of these should be addressed at the higher end of your Pareto. But these are some of the questions you would do in your trend analysis, and the statistical tools you would use in doing that, and charts that would generate. Now, bear in mind, the statistical charts you generate are usually ways merely to visualize the data, see how the data falls, if you will, which in some cases will point you in the direction you want to go for your resolution of the problem, or if not earlier, the finding of the problem. Obviously, we need to gather facts. So what are some of the facts? There might be looking at lot data for devices. That would be the device history record or batch lot or whatever. Other records, maybe you have control charts, which are very excellent tools in your production environment, a statistical tool. Review that. That'll show you the time when the process shifted, for example. And then you can examine what happened at that time. Was it a lot change? Was there a personnel change? Was there a power fluctuation, an air source fluctuation? It'll point you toward a narrowing of where to look. Photos are good across the board. If you're looking at failures on parts and maybe reoccurring failures in the same location, some photos to put in the file would be useful, and then that'll give you a point as to where in the manufacturing or molding process or whatever that type of defect might be introduced, allow you to go back to it. Equipment involved, whether it be test equipment, whether it be the production equipment that's being evaluated. Engineering lab books and or equipment log books would be useful to review, as well as V&V documents. Verification and validation, test reports, protocols, interviews. Sometimes engineers, QA engineers, discount the importance of interviews, especially if they're a college-trained individual and they are going on a production floor, maybe talking to a person that doesn't even have a GED. Now, the person that is an operator that may not have a degree behind their name may be viewed as to what they say is not of that importance, but you'd be surprised. They may have the wrong conclusion sometimes, but they may have the right idea of what has changed, and they are a valuable resource to include in your failure investigation. And then, of course, exhibits, actual failed product, if you can get it from the field, for example, if a hospital complained. More and more, because of contaminated product, biohazard issues, you won't get those. But then sometimes you can simulate that and create that and then retain that exhibit or photograph it or do some other means to indicate what the problem is so that it can be looked at in the future and reviewed, not just by an investigator, but even by your own personnel if a similar problem comes up in the future or if the same problem comes up in the future, indicating maybe all the root causes weren't addressed or the right root cause hasn't been located yet. So bear in mind, this is more than just complying with regulatory requirements. These are useful tools across the board for the company itself. Now, bracket. I see this missed quite a bit for various reasons. Some of it may be incomplete analysis. Others might be legitimate reasons for whatever reason. And I see it basically in recalls where initially a certain narrow lot of product will be recalled, then you'll notice a recall that expands the lot numbers, and then maybe a third recall that expands them even further. So to the degree you can, it's better to bracket all of that up front. Determine how far did that problem extend. If you know the root cause of the problem, you can determine perhaps when it occurred. That will tie you back if you have proper documentation for your batches or lots. When it occurred, which lots have affected of, say, raw material, which lots of finished goods that you shipped out would be affected, and that'll allow you to do the recall, if you will. Now, of course, bear in mind that certain items, certain consumables may not be listed on a bill of material, may not have a lot number or part number. Certain manufacturing materials sometimes don't, although I urge you companies to reconsider that. Other things like that may not. And as a result of that, you may not be able to backtrack. Sometimes lot numbers aren't retained on, say, resistors and simple electronic parts, if you still use those kind of things. So these are the kind of issues you have to consider as a trade-off. When you're thinking of structuring your product line in terms of the documentation, the bill of materials, the part specs, the part number issuance, etc., you have to consider it on the other side. What if there's a problem? What do we do? Are we stuck pulling back everything, or can we some of these, are they problematic enough that we want to assign part numbers and lot numbers to them so that we can bracket more effectively? And then, of course, we're looking at other things, too. The RM is raw material, the equipment involved, the areas and sites involved if you're a multi-site operation under a corporate environment, procedures, work instructions, maybe something changed and something is in there that seemed innocuous but now is causing a problem. These are the kind of things to start questioning and looking at. And, of course, trying to get your hands around the end result as well. So we want to use a problem analysis process that you ultimately want to define. Even though I said earlier with that failure investigation chart, initially you may not want to, but ultimately you want to come up with a defined system that gives a certain amount of flexibility. Again, you want to identify what is the problem, not the symptom. Where was it observed? When was it observed? How far does it exist? May require some supplemental testing and research. And then you start looking at the root cause. And I mentioned 6 M's here. We'll explain that in several more slides. Further analysis steps, the fishbone diagram or the cause and effect diagram, process maps or flow charts, fault tree analysis, and failure mode and effect analysis. You probably already have this if you've done a risk management file and report. Under devices, it'd be ISO 14971. Under pharmaceuticals, it might be ICH-Q9. But these already use those type of tools. You may want to go back to those tools and look at them and see if they indicate to you where this type of problem might have occurred, what kind of failure might have induced that type of problem. Then some of the tools, Pareto charts, histograms, scatter diagrams. I'll show some examples of that. Control chart. I won't show an example of that, but we'll talk about it. The 5 whys that we've mentioned. And, of course, teams of personnel in the resolution of the problem, but also going out and visiting production teams, et cetera, to do interviews. And then, of course, as I mentioned earlier, this is not a nice linear approach. It's not sequential. I'm laying this out somewhat sequential, and you will do it somewhat sequential, but you'll deviate quite a bit. There'll be iteration, reiteration as needed throughout. And, of course, you want to document that to some degree so you can see that in the future and understand what you went through and perhaps refine your system over time, which you should be doing. Continuous improvement, if you will. Okay. Input analysis is important. The 2 tools for that primarily would be flow charts or process maps and the Ishikawa or cause and effect diagram. So let's look at the cause and effect diagram. I mentioned the 6 M's. That doesn't mean you have to tie it to 6 M's. You can use other terminology like I have in parentheses. It's nice. It looks neat if you want to use that, but there's no reason to do that. You can do whatever you want to. But generally, it's these 6 basic areas that are inputs to whatever manufacturing process you're dealing with. And your goal is to look at all the inputs that come into your process to determine which are the most likely inputs to have caused or contributed to this problem. And again, this is difficult. It's not easy, and sometimes you'll take some false steps. Again, I've laid it out a little further, and we'll take it a little further, and I'll have a couple more slides, one coming up and then one a little later. So here again, you see that all laid out. Now, the problem is stated in the box off to the right there. And you can put this on Excel. You can do it yourself. You can draw it. You can buy macros that do it from various providers out there. You can do it by hand, and I've done that as well. And this is a good start. I find that you rough in the basics under each of those categories that apply to your situation. And then once you go through that, you may find that, well, this one branch seems to be the most likely, seems to be is a key word. So you add some sub-branches. You may go to another diagram and just explode that one branch some more until you have the all possible inputs that seem to be the most likely source of the problem. May not be the final one, but may be what we call in one of our slides a probable cause. So then you start going down that pathway. It may be a false pathway, in which case you have to back out and go down another one, but at least you can exclude that one that seemed to be the most promising. But you begin to see that this is not just a nice, linear, neat scientific process. There's some false starts involved and some false pathways. This is a fancy process chart or flow chart. There's software that will help you do this as well as the last one. I like to use a very simple box diagram for the events, oval diagram for the input and output, start and finish, if you will. Circles for continuations, little circles with A, B, C for continuations. Diamonds for decision points like QA checks, etc. But this is another approach to take. There's all kinds of approaches out there. And there's a lot of, as I mentioned, software that will help you do this as well. But frequently, if you want to dive right into something, then sketch out freehand, if you will, or draw it in Microsoft Word or Microsoft Excel or a similar type of program, or Microsoft Visio, for example, or others. There's plenty of others out there. Six Sigma has a lot of these type of tools, and Just in Time has several of these kind of tools. Here's another example of swim lanes where you show things moving back and forth. This is good to resolve problems, to see if you're like a spaghetti diagram under Six Sigma or Just in Time, the way to see where things are flowing between various functions and determine whether there's too much mess there, but also it evaluates the functional relationships, which is useful. Fault tree analysis is a simple one where the problem is listed there off to the left, and the various inputs that could contribute to that problem are listed increasingly to the right. Now, there's two logic diagrams on this. The very first one to the left there is what we call an OR gate. In other words, everything entering in on the right side that leads to the left side's output pen won't write, everything under it, any one of those things can cause the problem. But if you move down more to the center, you'll see an AND gate. That's like an inverted U with a straight line on the bottom rather than convex line. That indicates that the two things in this case coming into that right side into the AND gate, both of those have to occur for the event at the left side to occur. So in most cases, when you're doing a fault tree analysis, you'll be using the OR gate. Any one of the inputs underneath that gate would lead to the output above that gate, or to, in this case, to the left of that gate. And you notice here a continuation diagram, in this case a diamond or a triangle off the very bottom there in the center with an A in it, take you to a different sheet where you expand upon that. And you could use a circle if you wanted to, different approaches. You can go to the internet and Google some of these and see alternatives out there as well. And some of your engineers probably have tools they developed when they went to school that they prefer as well, I've found. Failure mode and effect analysis, or failure mode effect and criticality analysis. You don't have to find the difference between that. As criticality, I list the RPN values, the possibility of occurrence, the severity of occurrence, or probability, and the effectiveness of control to minimize the occurrence, and the ranking, 1 to 5, 1 to 10, whatever. I have those numbers, the FTA numbers, those are actually traceability numbers that tie the failure mode back to an issue on an FTA diagram. There's any number of ways to do this. Most companies now use 3 failure mode and effect categories. They use a use one, a process one, and a design one. They may have a separate software or include software under any one of those 3 or all 3 as necessary. I like to, even with design, I like to trace design problems all the way to the end user. And when we're talking about risk in this category, product risk, we're talking about to the end user, whether it be the patient or the clinician that's handling the product, whatever it is. Anyway, those are useful tools to refer to, and if you don't have one, to generate and then refer to, but you should have one. It's expected by regulatory agencies, at least for products developed since the middle 90s, that you have such a document. And of course, now it's been defined under ISO 14971. That's a European Union document that was under consensus standard with the FDA. They accept the same thing. ICH Q9 for pharmaceuticals, again, using much the same tools. They give you various other tools, and they may be more appropriate to your type of operation. But generally, I default to a fault-free analysis and the several FEMAs or FMECAs, if you will. Now, obviously, with looking at all the inputs now, you want to throw out those that are obviously not involved, put a question mark on some of those that maybe could involve, but focus your attention on the most likely input sources that are leading to your problem. And this, again, is a little bit of subjectivity, obviously, based on your knowledge of the process or those that you interview and talk to, their knowledge of the process. And so you look at those, you evaluate them, you take them to their logical conclusion, so you can either accept it or reject it or still hold it in abeyance while you look at some other alternatives. So what are some of the tools that help us to do that once you've defined your inputs? Again, you look back to your cause and effect diagram and see how things changed when this problem started to occur. Again, you're bracketing its occurrence. Well, what changed at that point in time? You're looking at all your inputs. What is the most likely input or inputs that may have changed that would be related to this type of problem? And of course, you want to, in your analyzing the actual metrics that you're selecting, you want to tie it into what question you're trying to answer by collecting this data. And then that will determine what type of data and what type of tools to measure that data will you put in place. It may be temporary, so you determine, number 4, the period of time for the study. If it's permanent, then you just put it under change control and keep it out there forever. And how you're going to collect it. It's going to be automated, it's going to be manual, it's going to be a logbook, etc. And then you gather that data. Again, if this is a temporary thing, it might be gathered to a lab book, or it might be printed out on a chart that you collect into your failure investigation report, if you will. And then you group it in accordance to what type of input you're evaluating. Then you try to narrow it down to the vital few as opposed to the general noise, if you will. And you focus your problem solving on the vital few. And again, the vital few is based on a subjective decision. It may not be right. In most cases it will be, but in some cases it may not be. And again, that's part of the root cause analysis that you may have to revisit when you find out that you haven't really gotten the true root cause, or you have only gotten one of several root causes. What are some internal data sources? These are data sources within your company. Well, it'd be inspection data, QC data, and it could through the entire supply chain. Scrap and yield data, as I mentioned earlier. Production process control data, and you should be having that in place. That's part of your GMP requirements. Incoming component data. Maybe you have QC data by incoming component, part number, supplier even. And you look at that. If you're narrowing it down to a specific item, then you go a little further and see, do you have multiple suppliers for it? Is there a way to identify which supplier may have contributed to this problem? Maybe it is supplier-oriented. Sometimes that happens. Now, they will push back. So it's important to have the data. I've been in this situation where, fortunately, my data was inarguable, and when I was able to show that to the supplier, they capitulated and recognized, yes, it was their problem, not a competing supplier's problem. Equipment data. Is it in calibration, for example? What is your PM program? Was there a recent change in material or the equipment component? Did it have to be swapped out, repaired, modified in any way, shape, or form? Or was it drifting out of tolerance, maybe like a cutter or something? And then, of course, internal audits may point to some issues you had in the past in certain areas that will help you narrow down your problem. Device history records, verification validation files, training records, change control records, rework records, scrap and fall-off data, Non-conforming material reports or out-of-specification reports are sources of indicating perhaps where to focus your efforts of study and then add to by further data collection. Now, external to the company, obviously, would be complaints, customer complaints, employee issue, and sales personnel. So maybe your employees, maybe a complaint they found as a result of a verification or validation activity, QC information, non-conforming reports would be an internal, or excuse me, that would be external. So your employees might be doing servicing if it's capital equipment, or they're aware of the complaints from customers. Your sales personnel frequently will not report complaints like they should, but they may have had a complaint themselves registered with them from an individual, or they might have themselves had a failure on a demonstration, for example, and it never gets captured. And then, of course, non-company, maybe related to your family of product. Look up the FDA's MedWatch or their Manufacturer and User Device Experience database. And now, of course, UDI and GUDID will ultimately, hopefully, provide these kind of resources. Journal articles may sometimes indicate industry-type problems. And certainly, if you're aware of a competing company having an issue in some area that seemed highly extreme, you may want to revisit that yourself. I think of a few years ago, the issue in two of the big pharmaceutical companies regarding what ended up apparently being a change in the method of disinfecting wood pallets in Puerto Rico. It led to a multi-million-dollar problem, multi-million-dollar fines, massive recalls, and egg on their face by two big companies, one in particular. So these are the kind of issues to consider, even minor issues that now you're aware of exist somewhere else that could affect you. I urge the regulated companies to look at other industries as well. The last few months, look at some of the issues regarding falsified software in the automotive industry, or failure to recognize a problem with ignition switches, and on and on. These are the kind of issues you need to be aware of and say, could these things happen in my company? Could they have contributed to this particular issue? And then, of course, 483s and warning letters, and the FDA's website has databases to review for that. Further sources, field service reports, legal claims, warranty claims, ECRI reports, kind of the consumer reports of medical devices, related product articles, even not necessarily your own. And then they have to examine, now, how am I getting my hands around this problem? I've identified the problem. I have an idea of some of the potential sources of that problem. What can I do now to get better into it? Do I have to add some additional data collection? What is the data I want to collect? Is it measurable? What metrics are going to be involved? As I mentioned earlier, the FDA more and more is looking at this. Those of you in pharmaceuticals are aware of the process validation guidance document that came out in 2011, and some of the key principles in that which would apply to anybody, really. It says it's specifically not for devices, but the principles would apply. What are your key quality attributes? Do you know your sources of variance? Are you able to reduce variance within lots and between lots, homogeneity within lots and between lots, consistency within lots, between lots? So that's a key point, all tied around variation. And you measure that by things like this, or control charting, for example, is an excellent tool to sort special causes from common causes, as the late Dr. Deming would be talking about. And again, you notice we keep coming back to some of these things because you may be plugging this in at different times to narrow down your decision making, maybe put it in temporarily. An example of a Pareto chart, you notice how it tapers off to what gets less attention off to the right on this particular chart, but what would get your highest attention would be to the left in terms of frequency in this chart, obviously. Now, if you have something over in the retest area, that's second to the right, and that's a major area for safety and effectiveness, then that would be the key area to address. So this chart has to be looked at in terms of not only the quantity that's be reflected upon it for trends, but also would have to be looked at in terms of risk to the end user, which may cause you to focus on something smaller down, in which case you would have an explanation in your failure investigation documentation as to why that choice was made. Scatter diagrams, I didn't mention this earlier, but this is another statistical tool. It's very useful to start seeing where things are occurring and where do I want to focus my effort on. It's amazing. Maybe for cavity analysis and molded parts, those are areas to consider these type of very simple tools. You don't have to be a statistical expert to utilize these tools and to quickly see, depending on how you structure the tool, quickly see what those tools are telling you the data is pointing you toward. It's a good way to take a lump of data and break it down in a way that it starts telling you something. Run and trend charts are very similar to control chart, except the run and trend chart tracks a value continually individually. The control chart may take 5 readings over an hour and then average those 5 and plot that average. And then as you see things moving along between basically 3 sigma, you're able to determine what would normally occur based on statistical distributions versus what's happening in my process. What's changed in the time frame, because you're plotting those points in terms of a value regarding your distribution, but also in terms of time. Each one of those averages, they're averaged out 5 readings during an hour, then that hour, that average is plotted, and so on. So you start seeing that plot, and if it suddenly does a shift over an average of 5 readings shifted, something's happened. Maybe good if it shifted up, maybe bad if it shifted down, but if something happened. May not have gone out of parameter, may not have gone out of acceptance range, but something happened as an early warning to tell you where to look at. We showed you an example of the scatter diagram, and then I just mentioned the control chart, a very useful tool as well. Okay, now these steps that I'm mentioning here, these 1, 2, 3 steps, are just under the one subject of analysis here. It's not those 4 key principles. But now if you've done this you're gathering data, you're charting the data, you're trying to see what the data is telling you, it should start to be pointing to the root cause along with your 5 why analysis. All of this should be narrowing it down to where you need to be. If not, you need to revisit some of those and plug in some additional areas. You've got several probable causes. Now you want to consider which is the most likely actual cause or causes. And then once you think you've found it, then you want to maybe do some means of testing or checking to verify, in fact, that it is the actual root cause or one of several identified root causes. Okay, again, we mentioned the 5 whys. You may be going back and forth on that. And of course, you notice here that your root cause may have several other causes associated with it, and I've listed just a few here. Now, training, you have to be careful with that. Training is like retesting. It's a cop-out. It is necessary. There's no getting around that. But if that's your only solution, that's your only root cause, it is probably not the real root cause. It's an ancillary item that's important and can't be neglected. But many times I see that's a quick way to sign off on a nonconformance. So retest it, which is a violation of statistics, a violation of your acceptance sampling principles, etc., or retrain, which is, to me, a cop-out. In most cases, there's another problem you address, and when you change something, obviously, then you do have to retrain, period. But it's a follow-on. It's not the be-all, end-all. It's not the root cause. And very, very few cases would ever truly be the root cause. In most cases, training's pretty poor anyway, what I observe in many companies. Okay, now again, the problems, maybe you are solving the wrong thing. You're not, haven't identified the problem, you're still dealing with the symptoms. But once you determine what the problem is or think you have, then you start evaluating the inputs to it. That's dissecting it and list them, and then narrow it down to the various tools we mentioned to get at the root cause, then you will have to verify that it is in fact the root cause. And when I say verify, that usually means testing. Okay, basic step number 3, find and implement the solution. Now, once you have the root cause, it may point you to the right direction. But get your team together, and that team should include people that are actually doing the work. Doesn't mean they're all university graduates, as I mentioned earlier. Bring in anybody that is knowledgeable about the process, even the most unlikely individual if they appear to know what's dealing with, or find out whether they appear to know that. Now, brainstorming basically means getting ideas without any kind of condemnation. Get the ideas out there. I've seen teams paste them on the wall, for example, with sticky notes or sticking pads, whatever, or using tablets or whatever. But generally, I've seen it done with the pencil and paper and the pasting on the walls. Get the ideas there. Then look at the most obvious ones that are related to your area. Slowly weed out some of those that may not apply, but keep them just in case you want to revisit some of those. Look at offshoots. If you see something that's been brainstormed as a suggestion, it mentions divergent thinking. Look at some, even if it's somewhat ridiculous, some alternatives, some 180-degree approaches or issues to make sure you've exhausted all things, especially if you're getting in areas where you're really having a tough time with the root cause analysis. And then, of course, narrow it down with convergent thinking, now working towards a solution. So now you've got all the ideas out here. You start winnowing those ideas to the most logical, and now you're starting to pull them together, and now you're using additional tools to try to verify which of those ideas are the legitimate root cause. And your ultimate goal, of course, is to eliminate the problem. You want to fix the problem. So here's some of the steps you'd go through to do just that. Come up with solutions. Now, I like to use the term that's on my website, completed staff work. That's taken from the military. In all honesty, and QC is a big violator of this, QA, it's easy to find problems. Nothing can be easier than find problems. And sometimes individuals tend to pride themselves on the fact they found a problem. Well, it's good to find problems, yes, but it's easy. The tough thing comes to resolving the problem, figuring out the solution. Completed staff work basically said if you find a problem, you come up with several solutions to the problem and then a recommended solution and the reason why that's recommended over the others. That creates issues. I like to encourage, when I had a QA department, I encouraged the QA department to be not just the problem finders, but part of the solution, be part of the team. Work with the manufacturing and engineering in resolving the problem. Many times QA may be in a position to point everybody in the right direction, or at least narrow out, eliminate some of the inputs that are obviously not applicable. But be part of that, because the fix to the problem is the hard part. The finding of the problem is not. Then, of course, once you have identified the solution, at least the assumed solution, you want to ensure that it is the right solution. You do verification or validation. Verification to me is testing, inspecting. Validation is a sum total of all the testing and inspecting. That's my working definition of those terms. And then you need to monitor to make sure you have, in fact, identified the right root cause or causes and implemented the right solution to that. And again, getting back to this, if you're seeing it revisited or coming back, am I just solving a symptom or am I really solving the problem? Let's say I mentioned earlier a problem with the device might have been traced back to an actual process problem in building the device, manufacturing it, or molding the parts. You need to apply the fix. This may be offline, it may be in a lab book, for example, and test it. and see if you can toggle a problem on and off. If you can toggle a problem off with that fix, more than likely you've identified the root cause. Not always, but more than likely you have. There might be something, interaction there, which DOE sometimes can find, design of experiments. And of course, you keep doing this, reiterating until you finally put it to bed. Now, you may put it to bed thinking you have resolved it, and it may, as I mentioned earlier, resurface, in which case it could be that you haven't identified the root cause, or you identified one of the root causes and more than one, or something different has started resulting in the same type of problem, which is also a possibility. So these things would have to be revisited. This is why your documentation in the previous effort is important, because if somebody's coming back to look at something that appears to be the same problem, they'll want to see what was done beforehand, what were the false pathways, what led to the end result. Did this apply now to this new situation or not? And so it becomes a very useful tool, providing that the documentation is able to be understood when it's referred to by a different person, maybe months later. And surprisingly, you'd be surprised how much of documentation does not stand that kind of test, to the embarrassment of the company and the one signing it. Identify various impacts. Now, here's where I get to that point I mentioned earlier about a couple of different impacts, the word impact. Here we're looking at impact to the end user. This is the more commonly accepted term of impact. So you're looking to the patient, and other end users might be the clinician, the technician at the hospital that handles the product or the pharmaceutical, etc. Products on the marketplace, interactions also there, GMP compliance issues, compliance to your quality system, the effect of the quality system upon the activity and vice versa, customer satisfaction, marketing issues too. So you begin to consider the impact of this problem on these other areas and resolve those you can. Some of this might be in the preventive category rather than corrective category under CAPA. But now, there's also another definition of impact. This is the one that I see neglected in CAPA. When I teach webinars and workshops on CAPA, I add impact as part of CAPA. Remember, I've also added C, correction. But impact is, right after correction is an analysis. Once you determine the cause of the problem, that cause may be a poor product spec or part spec. If it's a poor part spec, something's wrong in the part spec that has to be changed. Now you have to look at the entire supply chain. You have to look at what's in the rec stage, purchase rec stage within your company. What's in the purchase order stage in your company and also in the pipeline and at the customer, at the supplier. What's having shipped the supplier, what's in the pipeline to your receiving dock, what's on your receiving dock, what's been inspected and in the various process of being accepted or rejected, what's in your raw material inventory, what's in your WIP, work in process inventory, what's in your finished good inventory, what's in your distribution center inventory, what's in the pipeline there to the customer, and what's at your customer. So you begin to see this kind of impact analysis. I see a lot of weak points whenever I examine recalls and problems with getting product off the market and getting the pipeline cleansed, if you will, from start to finish. So this is an important area to look at, and it's an important area that you have to determine now, how can I get my hands around it should this happen in the future? How do I structure a new product? How do I structure the bill of materials, the part number, etc., so that I can get my hands around it, given the problem of some of these areas, which is problematic. How do I want to do it? What would be cost effective? What's the trade-off? All of these issues. Easier said than done. And you begin to see how widespread root cause analysis, how its tentacles, if you want to use that term, reach out into many different areas. And of course, you're resource constrained. So I'd urge you to prioritize what we're talking about here in terms of what can I utilize that has the biggest bang for the buck, and gradually incorporate some of these other tools as they are needed. Sometimes they won't be. Okay, I included this Plan, Do, Check, Act from the late Dr. Deming. There's variations on this under Six Sigma, but again, what we've been talking about involves a lot of these things. Planning gets into the investigation and the analyzing. Do has to do with, once you made the determination of what the problem is, resolve it. Then you have to monitor it, and then you have to make sure that that holds and make sure it's formalized or institutionalized under change control, and then monitor it again. Continue to monitor. So you would define how this would apply, but again, you know, it's a continuous circle that should involve improvement of quality. Now again, as I mentioned earlier, the old process validation guidance document came out a few years ago for pharmaceuticals. It incorporates the principle that over the life cycle of a product and process, you as a company should grow in your knowledge of the process and product and sources of variation and means of driving down variation. And in doing so, you should be improving your product and your process over time. So the FDA recognizes you're going to grow in your knowledge and you're going to incorporate that growth in knowledge and improve product and process. All of that's tied in with this principle, and it's all tied in with this failure investigation under root cause analysis. Again, you may have short-term solutions. You may be initially doing this to determine what is my long-term solution, or it may be all you're needing. Preventive maintenance and repairs. Step in and resolve that. Or maybe it wasn't done properly. Maybe the frequency is wrong. Those kind of issues. Long-term may, and here's where Dr. Deming, one of his 14 principles, comes into play. We don't blame the production person. We blame senior management. FDA's incorporated that. One of the key areas under quality system inspection technique for devices is management responsibility. One of four, the GMPs are distilled down into 4 areas, one of them being management responsibility, senior management responsibility. Or sometimes the FDA defines it as senior management with executive responsibility, the ability to change things. Your rank and file production person doesn't have that ability. Your senior management does. So there has to be, they have to be in the loop and have a desire to make changes to improve your company. But that involves buying new equipment, redesigning product so that you're not inspecting quality in, which is another principle of Dr. Deming and also in that process validation guidance document, but it's designed in, considering human factors, etc. And then maybe developing automated verification and inspection equipment, 100% automated, not dependent upon people, if you will. Again, you need to provide documentation. Now, some of you might be familiar with the new guidance document that's been out on dealing with data integrity from the FDA. One of the big things they talk about in that guidance document is an audit trail. If you're familiar with 21 CFR Part 11, it talks about audit trail. Very important. In paper documentation, you have an obvious audit trail. You can see who made changes, when they were made, what was changed. With electronic documents, you have to have this capability as well. And that's not readily apparent, but it has to be there. Part of your Part 11 validation would be verifying that there is an audit trail. So you can determine when an electronic record or signature was changed, who made the change, why it was changed, all those kind of things, the nature of the change, etc. And then we mentioned here the objective evidence necessary. We're dealing with not anecdotal information, but factual data. That gets back to your type of metrics you're gathering, and it should be measurable, it should be quantifiable, if you will. Okay, our last step here, number 4, monitor for effectiveness. This would include initial verification and validation, and then, again, like that process validation guidance document brings out, ensuring that your validated systems stay in a validated condition. That doesn't always mean revalidating. It may mean maintaining it by various other principles. I mentioned control charting as a good example. But other SPC, statistical process control techniques to ensure you're running a proper operation. although we're not under the foods from the FDA, they have HACCP, Hazard Analysis and Critical Control Points, where they basically distill the manufacturing process evaluation to 70 key areas to determine what determines your critical quality attributes of your product, and how can I monitor those control points to make sure that they stay in a state of control and that there's an early warning system that they drift out. Again, I get back to one excellent tool there, the control chart. But obviously, when you're doing root cause analysis, you're making a change to something. You need to make sure that that change does what you expect it to do and does not do what you don't expect it to do. So again, that gets to the point, was it effective or not? I should mention, any time I gloss over something that you want expanded, consider it for question and answer. I have a lot of information. I won't be touching on all the points. If you had expectations when you signed up for this course, you feel they weren't addressed, use that as for Q&A, and use it beyond this time frame. If you think something that's a couple of days, direct it to my attention through Compliance IQ. I'll respond to it. If it's a general interest question and answer, it'll be sent to all of you in attendance. If you think of something months later, contact me either directly or through Compliance IQ, and I'll respond to the individual question or point you in the right direction. Now, obviously, a lot of root cause analysis revolves around your CAPA system. So you obviously are tied into a corrective action report, a preventive action report, a supplier corrective action report, a supplier preventive action report, etc., which would address these kind of things. Pretty much some of the key areas that are addressed in that investigation template. But again, you may just have a space for a few line items. You would have an attachment then if you have an extensive amount of information that you want to compile, and you attach it to it or cross-reference it with a control number. And you want to make the change permanent. I actually worked for a boss one time that enjoyed firefighting. He liked the management attention he got. It was a he. It was frustrating to me. I could see ways in which we could institutionalize a change and permanently resolve it and get it out of the way so we could deal with other issues. And he tended to fight that program. He liked the attention he got when he stepped into a firefighting mode, and the company basically rewarded that type of behavior. Really, though, the goal is to find a problem, eliminate the problem, eliminate the need to do firefighting on that problem, put it to bed so you can move on to other things. There's always going to be new problems or reoccurring old problems with different causes behind them. But again, when you make a change, you have to do change control. If the change affects a product that's, say, 510K or PMA, you've got to analyze that change to determine whether you need to file a new 510K. And there's two new guidance documents out there to help you to do that, plus the K97 memorandum from the FDA to help you to make those decisions, but they have to be made. And under drugs, there's other more involved procedures to do that. And of course, verify, validate. To me, verification is a series of tests, and validation is a sum total of all those tests to prove that you satisfy the requirements of a particular piece of equipment or process, etc. And it should be objective evidence, proper metrics, if you will. Now, you may find in the root cause analysis that you head down a wrong pathway. Jump out of the process, make a notation to explain why. So it's obvious you didn't just drop the ball, so to speak. If it becomes evident through, say, another course of action by someone else or somewhere else, or that your course of action leads you to a previous study, then you can jump out of the process there and stop it and refer to the previous study, which resolves the issue. For some reason, in your particular area, it wasn't applied or didn't apply, but it's applicable, whatever. But there are occasions where you'll want to stop the process, in which case, document it and do your cross-referencing. Quick review. You need to capture the source of all problems, both internally and externally. Internally is usually not a problem. We have GMP systems in place to do that. Externally is more of a problem because maybe you have gatekeepers. Somebody calls in with a problem, they get the receptionist, and that receptionist routes them to maybe the help desk. tech support, customer service, marketing. Sometimes in marketing or customer service or tech support or help desk, some of them may not record it as a complaint. So you need to make sure you're getting all that. You don't have gatekeepers that go beyond what is the GMPs require, so to speak. Multi-site or multi-corporate environment communication, the FDA many times has 483s and warning letters because of breakdown in communication between plant sites within a corporate environment where it's necessary. And of course, you want to deal with individual problems as well as trends, as we mentioned earlier. And use proper metrics, collecting the proper metrics, determine how you're going to do that and how to react to that using the tools we've discussed here or others you may choose to use under Six Sigma. Remember, statistics is only as good as the data and assumptions you're collecting. You may be collecting wrong data, get some good figures and good analysis, but it's inappropriate to what you're trying to resolve. And there's tremendous, powerful computer tools out there that allow us to do a lot with statistics, sometimes without even understanding the principles behind what is going on in the algorithms that are driving those programs. So it's important to the tools I mentioned are very simple, easy to understand, easy to explain, and can solve probably a high percentage of your problems. You need more sophisticated methods, utilize those, but make sure that the individuals who are utilizing them understand the underlying principles behind them and the importance of the proper inputs to them. I remember studying in college a book called How to Lie with Statistics and writing a term paper on that. So it can be done. Okay, again, use your data that you find. It's one of the biggest causes of 483 observations if you look at their database on 483 observations. Make sure you have senior management support, and again, that's easier said than done, but sometimes publicizing with legitimate data and dollar values will get that attention and support. And again, your findings in your CAPA and root cause should feed into your production process control. In fact, QSIP, Quality System Inspection Technique for Devices, spells that out with one of their flow charts. You can get feedback into or out of verification and validation data. It may drive this, or it may resolve it. Same with your risk management files and reports. And we already talked a little bit about Part 11 issues. A couple of observations. You notice there was a 483 observation that there was no investigation conducted when there was a problem. For the second bullet point, results were not investigated, no identification of the isolates in terms of a pharmaceutical company. No product impact assessments. We talked about, basically this would be one dealing with the safety and efficacy issues, but also can affect other areas as well. Okay, and again, make sure we're addressing problem, not symptoms, which sometimes you won't find out till you're actually getting into it because you thought you did. Use the various tools we talked about here as well as others to narrow down your inputs to the most likely inputs and thereby narrow you to the solutions, the causes and the solutions, and then verify that what you identify as a solution is in fact a solution. And keep monitoring to make sure nothing shifted or that you did get the right thing over time. I mentioned entropy earlier, and this is a fact that if you leave things alone, they'll generally degrade. So if you solve a problem, you report to the FDA you solve the problem, if you don't go back to it, even though you really did solve the problem, if you don't go back to it, more than likely it, for the same reason or a different reason, will reoccur. And then you almost guaranteed a warning letter and the FDA thinks you lied to them. So it's important that you revisit problems you've had in the past, major problems, 483 observations, warning letter observations, and go back to those on a periodic basis to make sure they haven't come back and get rid of them if they have, and I guarantee you some of them will. And again, your goal is, these are some of the tools that help you prove you're in control, not just statistically, but in control regarding the GMPs. So I mentioned QSIT again for devices, but the same principle applies across the board. You notice management with executive responsibility is responsible for this to occur, and that applies to pharmaceuticals as well. Now, your company, though, benefits beyond just regulatory compliance. It sees these other areas reduced as well. It gets the basic Dr. Deming, the old Toyota production system, which he was a major contributor toward back to World War II. So there's more to it than just complying with the regs. It benefits your company and the quality of your product you ship out, and reduces costs in the long term, although there might be an initial cost up front for implementation.